everyone, welcome back. Today we're going to start talking about momentum. Now, momentum is actually a word that we use in our everyday language that we use pretty correctly. Think about something in your mind right now that has a lot of momentum. Typical answers I would get is a moving train, a jet flying through the sky, a comet, a planet revolving around the sun. They all have a lot of momentum. Now, you may have noticed all those objects have a very large mass, relative to the human body anyway. However, it is possible for something for a relatively small mass to have a lot of momentum too. For example, a bullet being fired has a lot of momentum, not because of its mass, but because of its velocity. Something to keep in mind. Whether it's a slow-moving train or a fast-moving bullet,
it is difficult to bring either of these objects to a stop.
And that is because they could either have a large mass or a large velocity or both. So we're going to start with this as our definition for momentum. A conserved quantity of a system measured as a product of mass and velocity. This is actually going to make the math for basic momentum pretty simple. We're going to use this. Now I know P is a pretty strange symbol for momentum. It actually comes from an old Latin word called petere, which could be translated to momentum. This is the object's mass and the object's velocity. Another way to think about it is M was already taken by mass, so they had to use something else. Now, one thing I want you to notice right now, mass is a scalar, but velocity is a vector. You multiply these, and that means momentum is also a vector. That means everything we have done with vectors up until this point counts for momentum as well. The directions, right as positive, left as negative, vector addition, vector breakups, all of it. Any variable that is a vector is treated in the same way. While I'm here, there's something else I would like to mention. There's a word in physics that I actually do not like to use, but if you're in a first-year physics course or an AP1 course, then you're probably going to see it. And that word is inertia. So when people talk about inertia, these are the properties they're actually really talking about. Mass momentum are the actual quantities people are talking about when they say the word inertia. This is an actual definition for inertia at the bottom, the property of a system which allows it to resist a change in velocity. So in other words, if an object is stationary and has a large mass, it's going to take a lot of force
or a lot of time
to change that object's velocity. If an object is moving and has a lot of momentum, it's going to take a lot of force
or again a lot of time
to change that object's velocity. So it's kind of an all-encompassing word. I don't like to use it because inertia is not something that can be measured. It does not have a unit. It is a very old word that is used in discussion, but in terms of a physics course, it's too broad a word to really use that often. So we're going to keep things nice and specific.
Momentum, the product of an object's mass and velocity.
So let's do some simple questions here. Little Timmy, who's 20 kilograms, is riding a 90 kilogram pony to the left at 12 meters a second. We'll go through these real quick. Mass of Timmy, 20 kilograms. Mass of the horse, 90 kilograms. Velocity average is negative 12.0 meters per second. I could also put velocity constant here too. But if the velocity is not changing, that is also an average velocity. Momentum of Timmy is mass of Timmy times the current velocity of Timmy. Since the velocity is not changing, we don't have to worry about initials or finals. 20 kilograms times negative 12 meters per second equals negative 240. Now, what are the units for momentum? Well, there are no special units for momentum, so it is merely kilograms times meters per second. It's literally the units multiplied together. Momentum of the horse is mass of the horse times velocity of the horse would be 90 kilograms times negative 12 meters per second gives me negative 1080 kilograms meters per second. What is the momentum of both? Momentum total. I could do this two ways. I could either add these two momentums, or I could do mass of Timmy plus mass of the horse times the velocity, which would give me 110 kilograms times negative 12 meters per second. And the total momentum would be negative 1320 kilogram meter per second. So I have negative showings going to the left because this is a vector, and there are no special units for momentum. Okay, another important quality about momentum is that momentum is conserved. In other words, as long as nothing from outside the system messes with your system, you always have the same amount of momentum. Another way to think about it is, as long as no forces from outside your system affect your system, momentum is conserved. So to show you an example, let's take a look at this one. A 0.4 kilogram baseball is rolling to the right with a velocity of 8 meters a second. It hits a 7.5 kilogram bowling ball that was at rest and stops. What is the final velocity of the bowling ball? I have my baseball, which I'll call object A. I have my bowling ball, which I'll call object B. The baseball is moving to the right. So mass A is 0.4 kilograms. Mass B is 7.5 kilograms. Velocity of A initial is positive 8.0 meters per second. Velocity B initial is 0 meters per second. Velocity A final is 0 meters per second. So the question is, what is velocity B final? So as I mentioned before, momentum is a conserved quantity. So it cannot just disappear or be created. If I was to use this little chart over here for momentum, object A, which is the baseball, has all the momentum in the beginning. It hits the bowling ball, comes to a stop, which means when the problem is over, object B then has all the momentum. So first, let's find the momentum of object A. Momentum object A initial is mass A initial times velocity A initial, which is 0.4 kilograms times 8 meters a second, which is 3.2 kilograms meters per second. So that means the momentum of B final, since the baseball comes to a stop, has to be 3.2 kilograms meters per second. And since the final momentum of mass B is going to be mass B times velocity B final, mass B is 7.5 kilograms, and velocity B final is my unknown. If I divide out the 7.5 kilograms, I will get an answer of 0.43 meters per second. So the baseball transferred all its momentum to the bowling ball, but since the bowling ball has a larger mass, it will have a smaller velocity. And all my momentums are positive because my velocity was positive for the baseball and for the bowling ball after it was hit. Okay, so these are the basics. I'll end this one here. Have a good day. This is Mr. M signing off.